Morning students once again. So we are in the lecture 10 revision class of TMM1 subject for mechanical second year second semester students. So in this lecture 10, in the past lecture 9 we have discussed about the introduction of riveted joints, their design principles, the failures and the other efficiencies. Now in this lecture 10 we will discuss about the problems of the riveted joints, right? Yes, we'll start the session. So if you see the calculation of the holes diameters on the pitch, so this is for the single shear, this is for the double shear, where tau is equal to 60 MPa generally, sigma c is equal to 130 MPa. Like the diameter for a single shear is 2.57 2.75 t, and the double shear 1.37 t. So this all things you can see in the design data book. So after substituting this right hand side equations, we will get p minus t into sigma t is equals to pi by 4 t square into tau s, where p is equals to pi by t square by 4 t sigma t tau s plus t. Substituting tau s equals 60 MPa, 75 MPa, p is equals to so on. So with this, p is equals to 2.73 d for single shear, 1.86 d for the double shear. The equation 6.7 6.9, we will get the margin 2 mt tau s is equals to dt into sigma c, where m is equals to d by 2 sigma c into tau s. Next, substituting these values, we are getting sigma c is 130 MPa, tau s is equal to 60 MPa, capital M is equals to 1.8 d, where d is equals to 6 root t, which is known as Unwin's formula. So with this problems, with this formulas, we can start doing the problems. 29, 28, 49, 20, right? See the first problem here. Design a double riveted lap joint. First, study the question 2 or 3 times. What is given? Design a double riveted lap joint for MS plates of 9.5 mm thick. So the material is MS, you already know. The thickness is 9.5 mm thickness. Now calculate the efficiency of the joint. The permissible stresses are given. Sigma T is equals to 90. Tau S is equal to 75. Crushing stress is equals to 150. Now see the figure here. This is a double riveted lamp joint. Double riveted two joints. These are the two things. So roughly మీరు వేయండి. If you get a question like this, draw the figures roughly, very roughly. మరి వేగంగా రాయకుండా రఫ్గా వేయండి, అర్థమయ్యేట్టుగా వేయండి. So the pressure is pulling this side and this side. So this is a diameter, this is a margin, this is a PB. So general 4 parameters పెట్టండి. P అంటే ఏంటి, PD అంటే ఏంటి, PB అంటే ఏంటి, and D and M. Now start doing the first concept. What is the first one? Diameter of the rivet hole. First you have to కనుక్కోవాలి, design the hole. Now by using this Unwin's formula, d is equals to 6 into root t. So we know the thickness. మన క్వశ్చన్ ఏమి ఇచ్చాడు? Only it has given the thickness, t ఇవ్వలేదు, and the parameter values, stresses ఇచ్చాడు. With this we got d is equals to 18.5. Now what is the thing you have to find? You have to find the pitch. Therefore the shearing strength of the one rivet, pi by 4 d square into tau s. Apply this formula here, you are getting 20.16 kilonewton. Crushing strength of one rivet, sigma c into dt, is equals to 26.36. So from this A and B, it is seen that the rivet is weaker in a shear. The rivet is weaker in shear. Why? Because so the sigma t and crushing stress 150. Here it is very 26 only, very few, right? Now we require the tearing strength of the plate with the shearing strength of the rivets in a pitch length, then two rivets of the pitch length, that is sigma t into pdt, that is equals to 2 into pi by 4 t square into tau s. So after equating this one, p మనకి left hand side తీసుకొని right hand side values substitute చేస్తే pi by 2 dt square by t tau s plus tau s by sigma t plus d is equals to, ఈ వాల్యూస్ అక్కడ సబ్స్టిట్యూట్ చేసిన తర్వాత వీళ్ళకంటే p is equals to 65.7. The pitch should be such that head forming operation is not being hindered. The practice ఇవన్నీ అవసరం లేదు. ఒకవేళ ఎగ్జామ్స్లో వస్తే just find the p value, leave it. Next C and D, PB కనుక్కోవాలి back pitch. The back pitch is between 2.5D to 3D. Therefore, PB is equals to 3D and పెట్టుకుంటే 3 is equals to 55.5 mm. Okay. Next, the margin is M. 2mt tau s formula is equals to 2 by 5 by 4 is per tau s. So m ని పక్కకు తీసుకొస్తే వాల్యూస్ అన్ని సబ్స్టిట్యూట్ చేసిన తర్వాత you are getting 28.3 mm. So this is a margin. Next one is efficiency. So generally in this third unit, if you ask to design a rivet or a butt joint, a welded joint, so you have to find the diameter of rivet hole, pitch of the joint, back pitch, margin, efficiency of the joint, right? So coming to the efficiency of the joint, the tensile strength of plate per pitch P1 is equal to sigma T into PT. That is 90 into 65.7. That is 56.2. Next, shearing strength of the rivets in a pitch length PS is equals to 2 into tau s into pi by 4 d square. That is equals to 40.3 kilonewton. Next, crushing strength of the rivets in a pitch length PC is equals to 2 into sigma C into D into T. That is 52.7 kilonewton. The tearing strength of the plate with one hole in a pitch length PT is equals to tau T P minus C into T. That is 40. So this are all the formulas you can see in the design data book, and you can easily write the values. The shearing strength of the margin PMS is equals to 2 into tau s into MT. That is 40.32. Out of all this one, PS, PC, and PT and PM, the lowest is a PMS. This one, see here, this one, this one, and this one, and this one. Therefore, the efficiency is equal to PMS by P1, that is equal to 71.74 percentage. Finally, the design values ఏం చేస్తున్నాం, D కనుక్కున్నాం, pitch కనుక్కున్నాం, base pitch కనుక్కున్నాం, M కనుక్కున్నాం, efficiency కనుక్కున్నాం. So these are the simple things. Whenever you get a question in the third unit, design of weld or design of riveted, you have to do in this process. So ఏం కనుక్కున్నాం, 5 కనుక్కున్నాం, design diameter కనుక్కున్నాం, second one pitch కనుక్కున్నాం, third one base pitch కనుక్కున్నాం, fourth one B by M కనుక్కున్నాం, fifth one is efficiency. Next one, design of boiler joints. In general, the longitudinal joint butt joint is adopted. In general, for longitudinal joint butt joint is adopted, which are circumferential joint lap joint is. Longitudinal joint ki butt joint use chestam, circumferential joint ki lap joint use chestam. Longitudinal joint means longitudinally we are using a butt ante enti like this. Okay, plate ikkada pettestam. అదే circumferential అన్నప్పుడు ఎలా ఉంటుంది, రౌండ్ వన్, పెద్ద రౌండ్ వన్. సో ఇన్ సచ్ కేసెస్ దే ఆర్ యూజింగ్ వాట్, దే ఆర్ యూజింగ్ అ ల్యాప్ జాయింట్. అంటే ఓవర్లాప్ ల్యాప్ జాయింట్ అంటే ఇలా డిజైన్ చేస్తాం, ఇలా చేసుకుంటూ వెళ్తాం, అంటే ఇలా ఉంటుంది అనమాట. Okay, now here how to design for a longitudinal butt joint. Here the first one is thickness of the plate. By using the formula, thickness is equals to PIDI by 2 by efficiency plus 1 mm. These are all things you can see in the design data book, where 1 mm is allowance, PI is equal to internal steam pressure, DI is equal to internal diameter of the boiler shell, sigma T is equal to permissible stress of the shear stress. Second one is diameter of the rivets. The diameter of the rivets may be determined from the empirical relation D is equals to 6 root T. Okay, the diameter of the rivet should not be less than the plate thickness. Consider the diameter of the rivet should not be less than the plate thickness. Plate thickness contra diameter of the rivet should not be less. If the plate thickness is less than 8 mm, the diameter of the rivet is determined by equating the shearing resistance of the rivet to its crushing resistance. Next, pitch of the rivets. What is the meaning of a pitch? The distance between the two things. Okay, the pitch of the rivets is equals to the pitch of the rivet should not be less than the 2D. The maximum pitch P max is equal to CT plus 41.28 mm, where C is equals to constant. Next, fourth one is row or transverse pitch of the rivets. For equal number of rivets in more than one row for a lap joint or a butt joint, the pitch should not be less than 0.33 pitch P plus 0.67 D. Right? Next. So just మీరు design of a boiler అని ఉన్నప్పుడు just మీరు design of a longitudinal button ఇచ్చాం. Just write the thickness of the plate. If you know the formulas, write it, or else you can see the design data book and you can write the matter. The diameter of the rivets. Third one is the pitch of the rivets. Just you have to say that determine the pitch of the rivets, determine the diameter of the rivets, determine the thickness of the plate, determine the transverse pitch, determine the thickness of the butt straps. Thickness of the butt straps. That is T1 is equals to 1.125 D. Next one is margin. The margin is determined by M, that is equal to 1.5 D. Next, design the circumferential lap joint. ఇందాక మనకి డిజైన్ ద లాంగిట్యూడినల్ బట్ జాయింట్ తీసుకున్నాం. ఇప్పుడు మనం లాంగిట్యూడినల్ ల్యాప్ జాయింట్ డిజైన్ చేస్తే సేమ్ ద diameter of the rivets, the number of rivets, n is equal to steam load by shear strength of the one. Third one is the pitch of the rivets. Third one is the pitch of the rivets. Fourth one is the number of the rows. Fifth one is the selection of the type of the joint. Fifth one is a row or a pitch on margin. So these are the design points for calculation of design of longitudinal butt joint and the circumferential thing. Next, what are the assumptions should be done in designing the boiler joints? So what assumptions and these are the 6 or 8 assumptions that should be maintained for designing a boiler joint. Right? If you get a question, you have to write these points. There is a no bending stress in the rivets. The crushing stress is uniform. The shearing stress in all the rivets is uniform. The rivets fills the hole after the driven. The friction between the surface of the plate is neglected. Okay, the crushing stress is uniform. So the stress is equally distributed over the section of the metal between the rivets. So these are the assumptions to be made while designing the boiler joints. Next, let's see the problem. So the important problems where we will get in the main exam. The design of a triple riveted joint to join two plates of 6 mm thick. So plate thickness మాత్రమే ఇస్తారు. Stresses ఇచ్చారు sigma t, crushing stress and stress 60. Calculate ఏం చెప్పాడు, rivet diameter, rivet pitch, distance between rows, use the zigzag riveting, state how the joint will fail. So design data book by Mahadevan or KV Reddy lo you can see the how to do the problem. Okay, so only మనకి ఇచ్చింది as the thickness of the plate is less than mm, the diameter of the rivet may be determined by equating the shearing resistance to the crushing. Further joint okay. So in the solution అంతా ఇంత అవసరం లేదు రాయడానికి. ఓకే, సింప్లీ థిక్నెస్ ఇచ్చాడు, దాని తగ్గట్టుగా మీరు సింపుల్గా ఒక రఫ్గా ఫిగర్ వేసుకోండి. సో దిస్ ఆన్సర్ వాట్ యూ ఆల్రెడీ ఫైనల్లీ గాట్. ఓకే, హౌ టు స్టార్ట్ విత్ ద ప్రాబ్లం. ఫస్ట్ వన్, షేరింగ్ రెసిస్టెన్స్ Fs is equals to 5/4. సో దిస్ చూడండి, ఒకేలా బుక్ ఓపెన్ చేస్తే టేబుల్ 5.3bలో పేజ్ నెంబర్ 68aలో యూ కెన్ సీ దిస్ ఫార్ములా. షేరింగ్ రెసిస్టెన్స్ is equal to Fs 5/4 pi d square by 4 into n into tau. వెళ్ళిగా 141.370 square. Crushing resistance Fc is equals to this one. Okay, equating this to 1 and 2, we will get diameter T is equals to 12.73 mm. The nearest standard diameter of the rivet T is equals to 14 mm. Now next one is pitch of the rivets. So diameter వచ్చేసింది కదా, first one is diameter, we have got this formulas. Now the pitch of the rivets. The pitch of the rivets Ft, tearing resistance Ft is equals to sigma t into P minus D into T. So shearing resistance Fs is equals to into n into same n into pi d square by 4 into tau, that is this one. Materials కాబట్టి. Now equating the 1 and 2 we have, sorry, equating 3 and 4 we have P is equals to 72 mm. Next, the distance between the rows of the rivets, PB or PT. So this is a formula. Say this is the distance. Next, the mode of failure of the joint. The tearing efficiency mode of failure, tear efficiency P minus T by P is equal to 80.1. Crushing efficiency and this is a formula. So all the formulas you can see in this data. This is 80.2. The lowest efficiency indicates the mode of failure of the joints. In the present case, the joint will fail by crushing the riveted joints. Got it? Very simple problem, which is directly you can do it. Now take the second thing, a double riveted zigzag joint. So same reference, where the pitch of the rivets in outer row is twice. Outer row is twice that in the inner row twice. Connects the two 16 mm plates thickness ఇచ్చాడు with two cover plates each is 12 mm, right? Cover plates వచ్చేసి 12 mm and other thickness is 16 mm. Determine the diameter of the rivets and the pitch of the rivets and the pitch of the rivets. The working stress is so on. So okay, now what the first thing you have to find? Diameter of the rivet. Diameter of the formula d is equals to 6 root t, that is 24 mm. Next I'm going to call it pitch of the rivets. So PO is equal to pitch of the rivet in outer row, PI is equal to pitch of the rivet in the inner row. This is the inner, not outer, inner row. So with this, what is the formula you are getting? See here, double riveted, double strap, zigzag butt joint. The tearing resistance Ft is equals to P minus D, T into sigma T. That is this one. Shearing resistance confound Fs is equals to N into 1.85, 875 into pi by 40 square into tau. So after calculating this one, you are getting this one. Now equating 1 and 2, equating this 1 and this 2. Pitch outer is equals to 144 mm. Then pitch of the rivets in the inner row, PI is equals to outer by 2, that is 72 mm. Now the distance between the two rows of the rivets, you can see in this page number 66 of the data book. For the zigzag, the row pitch, that is 60 mm may be recommended, right? So if you are aware with this design data book, you can easily solve the problems directly by seeing this design data book. Okay. Next. Carry on my problems. Okay. So in class law we can complete this one, no problem. A double riveted lap joint is made of 15 mm thickness. The rivet diameter and the pitch are 25 mm and 75 mm respectively. If the ultimate stress are 40 MPa, 400 MPa in tension, 320 MPa in shear, 640 MPa in crushing, find the minimum force per pitch which will require the joint. Right? The factor of safety is 4. Find out the actual stresses developed in the plates. Now, what's the given thing? T is equals to 15 mm. The diameter of the pitch diameter P is equal to 25 mm and 75 mm. Pitch distance between the two rivets 75 mm. Ultimate stress is 400. Ultimate stress is 400. Tension, shear load 320, crushing load 320, 640. Okay, 640. Right, now find the minimum force per pitch which will rupture the joint. Right, therefore PTU is equals to P minus D into T into sigma into TU. So substituting these values, we are getting this one. Ultimate shearing resistance of the rivet per pitch, PSU, ultimate shearing resistance is equals to N pi by 400 E square into tau U, that is equal to this one. Finally you are getting this one. Now ultimate crushing resistance N into T into sigma CU, that is this one. From the above, we see that the minimum force per pitch which will rupture the joint is equals to 3000 kilonewton. Okay, so this is a minimum force per pitch. Now the actual stresses produced in the plates and the rivet. Since the factor of FOS is 4, FOS is 4 per pitch per length, that is equal to 3000, 3 lengths divided by 4, that is 75,000 newtons. Let tensile, actual and crushing, actual tearing, shearing and crushing stresses provided with FOS of 75,000 in tearing, shearing and crushing. The tearing resistance is equals to tau PTA is equals to P minus DT into sigma TA. That's equals to sigma TA is equals to 75,000 by 750. That is equal to this one. Actual shearing resistance of the rivet 75,000 is equal to n into pi by 4 or t square into tau A. So that is equal to tau A is equals to 75,000 divided by 982, that is 76.4. The actual crushing resistance of the rivets PCA. So after applying this one, CA is equals to 100 MPa, right? So like this you have to calculate the PCA is 100, PCA ikkadanta PCA CA tau A all are less than the actual stresses, so it is safe. Next one is finding the efficiency of the following riveted joints. Single riveted lap joint with 6 mm plates, 20 mm diameter, which is 50 mm. Double riveted lap joint 6 mm plates, 20 mm diameter, pitch matram 65 mm. So the stresses are tensile, shearing and crushing. So diameter, write the given data. T is equal to 60 mm for both, D is equal to 10 mm for both, sigma T is equal to 120, 90 and 180. Right? Now find the efficiency of the first joint. P is equals to 50 mm. Therefore, the tearing resistance of the plate PT is equals to P minus D into T into sigma T. That is equals to 21,600 Newton. Shearing resistance of the rivet. PS is equals to pi by 4 D square into tau. That is equals to 28278 Newton. Next, crushing resistance of the rivet. Crushing resistance of the rivet. Here, what is the crushing resistance here? So the strength of the joint PC crushing resistance is equals to D into T into sigma C. That is 21,600. Next, the strength of the joint. Therefore, the strength of the joint is equal to PC, PC, PS, and P tau is equal to 21,600. The strength of the unriveted solid joint P is equal to P into T into sigma T. That's equal to 36,000 Newton. And what the efficiency? Least of PT, PS, PC by P. ఈ మూడిట్లో లీస్ట్ ఏముంది 21,600. So 21,600 by the capital P 36,000. That is 60% efficiency we are having. Okay. So ఇక్కడ ఏమన్నారు సింగిల్ రివిట్ ఉంది తర్వాత డబుల్ రివిట్ ఉంది. Now the efficiency of the second joint, that is a double rivet, pitch is equals to 65. సో ఇందాక మనం పిచ్ ఎక్కడ పిచ్ మనం 50 mm అంటే ఫస్ట్ దానికి తీసుకున్నాం, ఇది ఫర్ సింగిల్ రివిట్. ఫర్ ద డబుల్ రివిట్కి సో ఇక్కడ సెకండ్ అన్నాడు లేదంటే మీరు డబుల్ రివిట్ అన్న వేసుకోవచ్చు, నో ప్రాబ్లం. సేమ్ ద టీరింగ్ రెసిస్టెన్స్ PT is equals to P minus DT into sigma T. That is 32,400 Newton. Now the shearing resistance of the rivets PS is equals to N into pi by 4 D square into tau. That is equal to 56,556 Newton. Crushing resistance of the rivet PC is equals to 43,200 Newton. Therefore, the strength of the joint least of PC, PSC and the more least 1, 2, 3. More least this one is the least. Now calculate simply the efficiency 32,400. So మనము ultimate undivided solid plate ki P is equals to P into 2 into sigma T కనుక్కుంటే we are getting 46,800. Therefore, least of TSC 32,400 divided by 46,800, that is 69.2 92%. So like this, we have to get the efficiency for this joint. Next, 9.3 question. Now, a double riveted double cover butt joint in the plates 20 mm thick is made with 25 mm diameter rivets in the 100 mm pitch. The permissible stresses which find the efficiency of the joint, taking the strength of the rivet in the double shear is twice that of the twice that of the shearing single shear, 2 times the shear అనమాట. సో గివెన్ డేటా ఇచ్చాడు, డి ఇచ్చాడు, పి ఇచ్చాడు, the stresses value ఇచ్చాడు. ఫస్ట్ యూ హ్యావ్ టు ఫైండ్ ద టియరింగ్ రెసిస్టెన్స్ ఫార్ములా వేయండి, ఇందాక ప్రాబ్లం లాగా వేయండి, యూ ఆర్ గెటింగ్ ద వాల్యూ పిటి. నెక్స్ట్ షియరింగ్ రెసిస్టెన్స్ పిఎస్ ఫార్ములా వేయండి, రైట్, పిఎస్ ఫార్ములా వేయండి, యూ ఆర్ గెటింగ్ పిఎస్. నెక్స్ట్ క్రషింగ్ రెసిస్టెన్స్ పిసి ఫార్ములా వేయండి, రైట్, సో యూ ఆర్ గెటింగ్ పిసి ఫార్ములా. ఈ మూడిట్లో తక్కువ ఏముంది, సో టేక్ 1,50,000. నా ఎఫిషియన్సీ ఎట్లా, P is equals to same ఇందాక పై ప్రాబ్లం ఎలా చేశారో అలా చేయండి, డివైడ్ బై 1,50,000 డివైడ్ బై 2,40,000, you are getting 62.5%. Next, take the third one, the design of a double riveted butt joint with 2 cover plates for longitude and seam of the boiler 1.5 meters subjected to steam pressure is 0.95. Okay, the joint is 75% efficiency, allowable stresses is 90 MPa, compressed stress is 140 and the shear stress same, D ఇచ్చాడు, P ఇచ్చాడు, efficiency ఇచ్చాడు, sigma T ఇచ్చాడు, tau ఇచ్చాడు. The thickness of the boiler shell plate T is equals to అన్ని యాడ్ చేస్తే is this thing. The diameter of the rivet D is equals to 6 into root D, that is 20.8. Third one, the pitch of the rivets. The pitch of the rivets, P is equal to pitch of the rivets. So tearing resistance PT is equals to P minus D into T into sigma D, that is where n is equal to 2. Why? Because it is a double riveted double strap butt joint కాబట్టి. Now double shear ki 1.87 times stronger than the single shear, we are having this formula, PS is equals to n into 1.875 pi by 4 d square into tau, that is equals to this one. Now equating 1 and 2, we are getting P value is equals to 90. According to Indian boiler regulations, P max is equals to, this is the formula, P max is equals to C into T plus whatever 0.28, that is equals to P max is equals to 84 mm. Therefore, since the value of P is more than P max, therefore we shall adopt the pitch of the rivets P is equals to 84 mm. So this is the final conclusion. You have to wait. Next, what the fourth one you have to see, this distance between the 2 rivets. What are the distance between the 2 rivets? PB. So assuming the zigzag riveting, PB is equals to 0.33 P plus 0.670. ఇవన్నీ మీకు డిజైన్ డేటా బుక్ లో దొరుకుతుంది. So after doing this one, you are getting the value is 40 mm. According to the thickness of cover plates, according to IBR, T1 is equals to 7.5 mm. Next ఏం కనుక్కోవాలి, మార్జిన్ కనుక్కోవాలి. M is equal to 1.5 D మనకు తెలుసు, that is round figure చేసుకొని 32 వేయండి. Now find the efficiency of the design joint. Efficiency, tearing resistance, PT same old formula, ఇది కనుక్కోండి. నెక్స్ట్ PS same old formula, ఇది కనుక్కోండి. ఓకే, PC same old formula, ఇది కనుక్కోండి. నా మూడిట్లో తక్కువ ఏముంది, 68,040 ఉంది. సో 68,040 పక్కన పెట్టండి. Now the strength of unriveted plate P is equals to P into T into sigma. So that is 84 into 12 into 90, 720. Now 68,040 divided by 90.90, 720. That is the efficiency you are getting is 75%. Since the efficiency of design joint is equal to the given efficiency of the thing, therefore the design is satisfactory. Okay, so like this we have to go with this thing. Next, a double riveted lamp joint with a zigzag riveting is to be designed for 13 mm plates. Assume the values. State how the joint will fail. Find efficiency. Same given data రాయండి. First diameter of the rivet కనుక్కోండి. Same old formula, D is equals to 6 into root T. Okay. Next, pitch of the rivets, P is equal to pitch. First tearing resistance తీసుకోండి. PT value కనుక్కోండి. You are getting this one. Pitch కనుక్కోవాలి. Therefore, the shearing resistance PS is equals to this formulas, we are getting this one. Okay, next from the equations 1 and 2. సో మీరు పిచ్ లేనప్పుడు ఇలా కనుక్కొని మీరు 1 and 2 లోపల ఈక్వేషన్స్ తీసుకొని దీన్ని సబ్స్టిట్యూట్ చేస్తే p వాల్యూ వస్తుంది. then the maximum pitch is p max is equals to 41.28. from the table shown in the given data book, the riveted for the 2 rivets per pitch per length, p max is equals to 75.8. therefore the p max is more than p. we shall adopt p is equals to 71 mm. The distance between the 2 rows of the rivets pb is equals to, after applying the formula, we are getting 40, right? Next, fourth one, margin. Margin m is equals to 1.5d value. Then we have to find the failure. Failure county, same old formula. Steering resistance pt is equals to this formula, you are getting 49,920. For shearing resistance, ps is equals to n95 before d square round. So you are getting this one. Next, for the crushing rivets, you are getting this one. So దీనిలో చిన్నది ఏది అది తీసుకోండి. Then efficiency, the least is this one. So here the joint will fail due to shearing of the rivets. Efficiency p కనుక్కుంటే ఏది solid plate కనుక్కున్నప్పుడు we are getting 73. So least ఏముంది 49 divided by 7840, we are getting 67.5%, right? So like this we have to, so like this we have to do the problems, practice the problems. So problems are all similar గానే ఉంటుంది. So I think majorly last 3 problems మీరు చదవండి. 9.4, 9.7, 9.3, 9.2 problems, right? 9.1, ఈ 4 to 5 problems మీరు ప్రాక్టీస్ చేయండి. So definitely you will get this type of similar problem in the exam. Okay, practice these problems well, right? So definitely to practice these problems. Okay, so definitely we'll get one problem from this slides, from these problems. Okay, okay, so these are the one problem 9.1, 9.2, 9.3, 9.7, 9.4. So practice these problems. Definitely we get some of the okay. So with this we can conclude the concept of riveted joints. So design of boiler joints తెలుసుకున్నాం, design of riveted joints తెలుసుకున్నాం, what are the methods of failure తెలుసుకున్నాము, right? So practice these problems and questions వచ్చేసి మీకు what are the methods of failure of riveted joints వస్తుంది, what are the types of riveted joints వస్తుంది, లేదంటే problems associated with this riveted joints. So next 11th lecture lo we will discuss about the concept of welded joints. So with this I can assure that if you practice these problems and the concept, definitely you will score good marks. And also the question assumptions in designing the boiler joints. Okay, what are the design the boiler joint అన్నప్పుడు మీరు circumferential and longitudinal butt joint మీరు తీసుకొని you can design the boiler joints. Got it? Any doubts? Just call me, I can clear your doubts. Okay, so with this I can close this concept. We will discuss next concept in the next session. Right? So problems are similar గానే ఉన్నాయి. ఓకేనా? Problems are all in similar things. ఒకసారి ప్రాబ్లమ్స్ చూడండి, ప్రాక్టీస్ చేయండి, డిజైన్ డేటా బుక్ పక్కన పెట్టుకోండి, do the problems. Okay. Right. So failure of the joint అన్నప్పుడు అన్ని కనుక్కోవాలి. టీరింగ్ రెసిస్టెన్స్, షేరింగ్ రెసిస్టెన్స్, క్రషింగ్ రెసిస్టెన్స్. వచ్చిన తర్వాత దీనిలో లీస్ట్ ఏముందో తీసుకొని షేరింగ్ రెసిస్టెన్స్ లీస్ట్ తీసుకొని స్ట్రెంగ్త్ ఆఫ్ ద అన్రిమిటెడ్ జాయింట్ తీసుకొని డివైడెడ్ బై పిఎస్ బై పి చేస్తే ఎఫిషియన్సీ. సిమిలర్గానే అన్ని ప్రాబ్లమ్స్ చేసుకుంటూ రావాలి. మార్జిన్ కనుక్కున్న తర్వాత రైట్ నెక్స్ట్ ఫెయిల్యూర్ ఆఫ్ ద జాయింట్ తీసుకోవాలి. ఓకే. సో లైక్ దిస్ వీ కెన్ solve the problems in this riveted joints. So with this I can stop the session here. We will continue in the next